Okay, hello everyone. Welcome to a new session. So, in our last session, we briefly introduced graph, and we learned how to represent a graph, and then we learned how to traverse a graph using the two most popular algorithms, BFS and DFS. So today, we will focus on actually writing Java code, like when we say that we can represent a graph using adjacency list. What does that mean? Today let's write the actual code and then use these two algorithms to traverse that. And in the next session we will create a matrix, and then using that matrix we will traverse that using these two algorithms. But in this lesson we will focus on representing a graph using a list. So let's take this graph as an example and let's create a list. Okay, so you know that this is a key value pair. So for a key value pair, map is the best option that we have. Okay, so let's create a map. So here you can see the keys are integers, but the values for these keys are arrays. That means a separate list. So let's say the key should be integer, and the values for these keys are list, and the value of this list are also integer. For example, it is 2 5 1 3 integer. Okay, and let's give it the name like list. Okay, we need to import these classes, map and list, from import java.util. Okay, so now let's create the constructor of the class, graph list equals a new hash map, Okay, so we have created the list, but the list is empty, and we need to add these nodes to this list. So let's create a separate method, and its job should be adding these nodes to this list. So public void add age. So every time we need to pass the two ends of an age. For example, 6 and 4. For example, 4 and 3, 3 and 2, 2 and 5, 5 and 1, 1 and 2, all of them. So entity U and entity V. So in the list, in the hash map that we are creating this list using the hash map, we have some built-in methods that we can use them in order to make our job easier. Otherwise, every time we have to check the list, like do we have this U and V in the list or not, like using conditional statements. But if you use those built-in methods, your job is much easier. So you can say that when you get U and V, you check, are they already existed in the list or not? If they already exist in the list, so you ignore them. But if they do not exist, then you add a key and then its values. So you can say list dot put if absent. You say put if absent. That means if the given node does not exist in the list, then you can create a new key value pairs. But if it exists, just ignore that. So you say for the key U, and so for every key, the value should be a list. You can say new array list, something like this. And also you check V also. for example, like this. Right now, let's say you have passed 1 and 2. So first you check number 1. You say list put if absent. That means if u does not exist, number 1, if does not exist in this list, then add that. And the value of number 1, the value of this key is of course a list. So you create a new list, an empty list. Okay, and then you say list put if absent. For v, the same thing. For example, let's say you have passed 1 and 2. You checked 1 and now you check 2 also. You say if v, or number 2, if it does not exist in the list, if it is absent, then add this, and the value should be a list. New array list. Okay, something like this. So you check, you added the key value in your list, and now like so far you have not been adding these new nodes in your list. You just checked if they exist or not. But let's suppose this number 1 already exists. For example, you have passed number 5 and number 4. So if 1 is already in your list, and at this time you have passed, for example, number 5 and number 4, so when it checks, it says number 5 does not exist, number 4 also does not exist the first time. So you create list like this. But if they already exist, so you just add the value for them. For example, at some point, if you pass 2 and 1, so you see that 1 is already exist. Or for example, you pass 5 and 1, so you have already 1 here, because when you passed 1 and 2, you had that 1 here. But this one that you have passed 5 and 1, so 1 exists, you only add its value. That means the value should be added in this list, number 5. So at this point, let's suppose you have passed number 1 and number 5. So you say that, well, 1 is the key here. Then you say list dot get. That means list dot get v number 1. And when you get that, so you can add number 5 to this list. Add number 5. That means u. Something like this. So when it exists here in the list, you get that, and then you add a new value in this list. So same thing with number 5. For example, if the 5 already exists, so you get number 5 from this list. You say list dot get number 5 and add v, like this. So now you are adding all the ages correctly. So later you just call this method and add all the nodes into your list, and then now that you have this list field like this, key value pairs, now you can use these two methods to traverse that. So let's start traversing this list using BFS. Okay, so let's come out of that method and say public void BFS. So you always you give a beginning or an initial point when it start. Okay, so when you use BFS, breadth first search, So you explore or you traverse the graph level by level, and you need a queue. And also you should have another set to avoid visiting the same node repeatedly. So you need to have a queue, and you need to have a set of visited list. So let's create them. First, we should have a set, because in order to keep track of the visited list, because in the set you don't have any duplicate values, and it is easy to check if anything exists in the set or not. So you can create a set, and of course our values are all integer. Set integer visited equals new hash set okay, and you need to have a queue. So queue, also the values are integer. Queue equals new. So implement this interface using a linked list interface, because it is very easy to add something at the end of a linked list, or remove remove. So generally you should know that queue is first in, first out, and using the linked list you can easily get the first element, and you can easily add new nodes to the last of the queue. So it is easy. It is a good option to have the linked list. Okay, so now as soon as you call this method, this BFS method, and you pass the given root, so as soon as the root is given, you add that root to your queue, and also you add that to your visited set. So you can say visited dot add start, okay, and also add this to the queue. So let's see, the given root is number 1. So we have added number 1 to the visited list, and also add this to the add this to the queue also. Queue dot add start. Okay. So you have added the given root in the queue and in the visited list, and you know that in BFS you explore level by level. So the next level is 2 and 5. So you need to have a while loop in order to check this queue, and you say that while as far as the queue is not empty, as far as something is in the queue, that means you keep traversing this graph. So you see, while this queue is not empty, queue dot is empty is false. As far as it is not empty, we have to keep checking that, and we have to dequeue the front element from the queue. So you say init dequeued node equals queue dot pull. Okay, so when you say queue dot pull, that means the first given node is deleted from that, like this. So when you delete that from the queue, you do your process, you check that. But here I just print that. Here we don't need to check any elements, but sometimes you are looking for some specific values. That is why you check them. Here we don't need to check them, we just print them. System.out dot print node. That's it. Actually make a space also there, because they should have a space, something like this. Okay, so you process number one, and now you need to check its neighbors. So number one has two neighbors, 2 and 5. Now you need to add them to the queue. So, and as far as it is a list, so you need to have another loop, maybe for loop, to go through this list and add all the neighbors to the queue. So go through that for anything neighbor, neighbor from list dot get node so you check all the neighbors of this node. You get that from here, list dot get dot node, and this node is a key, and that is number one. And when you say get number one, its value is 2 and 5, so it is an array. For that reason, you can use the for loop. So now you say, if these neighbors are not visited, add them to the queue. But if they are already visited, you don't need to add them to the queue. For that reason, you can check them. So you say, if they are not in the visited list, if they are not in the visited dot contains neighbor, N-E-I-G-H-B-O-R. So if that neighbor does not exist in the visited list, add this to the visited list. Visited dot add neighbor. So for example, the first one is number 2, so you add number 2 to the visited, and also add this to the queue. Queue dot add neighbor. Okay, so you add this number 2 in the queue also. Okay, something like this. So, and now the while loop continues. So again it checks, is the queue empty? Actually at this point your queue was empty, for example, when you removed number 1. But then when you process number 1, you added its neighbors. Now there are, so when you went through this for loop, you added number 2 and also number 5. So you added both of them, number 2 and number 5. Okay. And now, is the queue empty? No. So pull the front value, and that front value is, so it was number 2. Okay, so remove number 2. Remove number 2 and process that, and now check the neighbors of number 2. So number 2 is here and the neighbors is 1, 3, 5. So you need the for loop, and you need to check if that neighbor is already visited, fine. But if not visited, add them to the visited list and the queue. So when you are here at the 2, so number 1, is number 1 already visited? Yes, it is already visited. So you ignore this F and you go to the next one. The next one is number 3. Is number 3 visited? No. So you add number 3 in the visited list and also add number 3 in the queue. Okay. So go to the next one, number 5. Is number 5 in the visited list? Yes, number 5 is already in the visited list. So you ignore that and you go to the next while loop. At this time, again, the while loop is not empty. So you remove the front value from the queue, and that was number 5. Okay, you remove that number 5, and then you process that number 5, and then you check the neighbor of number 5. So when you check the neighbor of number 5, it is 1, 2, and 4. So 1 is already visited, 2 is already visited, number 4, it is not visited. So add this to the visited list. And also add this to the queue. Okay. So now, again, the while loop continues. The queue is not empty. There are 2 elements. So you remove the front value, which is number 3. You remove that. And now you process that. Then you check the neighbors of number 3. It is 2 and 4. You check if they are already visited or not. You see they are already visited. 2 and 4 are already visited. So you don't add that. And the while loop continues. Still, is the queue empty? No, the queue is not empty. Then remove the front value or the front node from the queue, which is number 4. So remove number 4 and then process that number 4 here, and then add the neighbors of number 4. So the neighbors of number 4 are 3, 5, and 6. So is 3 already visited? Yes, 3 is already visited. How about number 5? Number 5 is also visited. How about number 6? It is not visited. So add that to the visited list. Number 6, and also add this to the queue. Okay. So we added that neighbor to the visited list and also to the queue. So now still the queue is not empty. So you pull that front value, which is number 6. So you pull that, and then you process that, and then you check the neighbors of number 6. The neighbor of number 6 is only 4, and 4 is already visited. And at this point, your queue is empty. When the queue is empty, that means you have checked every node in the graph. And see, you have checked all of them. 1, 2, 5, 3, 4, 6. And see, they are visited level by level. For example, you have number 1 here. The next level is 2 and 5. 2 and 5. The next level is 3 and 4. 3 and 4 and 6. So this way you visited all the node in this list. So it was using BFS. Now let's see how we can do the same thing using DFS. Okay, let's create another method. Public void DFS. Again, we give the start value, the initial root. Okay, so when we use DFS, we explore as deep as possible before backtracking. For example, if we start from number 1, we either come here or we either come here. So, and here we need to have a stack. For the breadth first search or BFS, we needed a queue, and for the DFS we need a stack. Okay, so, and also we need that visited list also for this one as well, because we don't need to repeatedly visit the same node. So let's create a visited set. Of course the values are integer visited equals new hash set integer. Okay, and now let's have a stack. Also the values are integer stack equals new. We have a concrete class of a stack. We can implement that. Okay. So we have our stack and we have our visited list. So as soon as we call this method and we pass the given root, the initial root, so we put that to the stack. We say stack dot push start. Okay. So for example, let's say again we start from number 1 and I put that number 1 in the stack. Okay. So I put number 1 in the stack, and now I keep checking the stack. As far as there is a node in the stack, I check that unless the stack becomes empty. So I say while the stack is not empty, stack dot is empty. So as far as the stack is not empty, we have to keep processing them, and we need to pop the last inserted node in the stack. Init node equals stack dot pop. Okay, and that is number 1. So when you call that, you remove this. Okay, now it is removed. So you process this now, and also you say if it is not in the visited list, you process that and you put that in the visited list. But if it is already visited, you don't need to process that again. So you say if it is not in the visited list, visited dot contains node. If it is not there, add this to the visited list. Visited dot add node. So we add number 1 here now. Okay, number 1 is added to the list because it was not there. Okay, so now here, as soon as you add it to the list, you process its value also. If you are looking for any specific values or whatever process you need, you can do that here. But right now here we only print them. Okay, so let's say system.out.print and node. Okay, so we visited number 1, and now we need to get its neighbors, which is 2 and 5, and we have to put them in the stack also. So we need to have for example, number 1, its value is an array, so we need to have a for loop to go through this array and put them in the stack. So you have to have an array for anything neighbor list dot get node. So when you go through the neighbors through this list, check them. If they are already visited, ignore them. But if they are not visited, then add them to the stack. Because if it is already in the visited list, that means at some point it was in the stack. Because you see, we removed that from stack and then we added this to the visited node. So for that reason, you say for init neighbor list get node, you say if it is not in the visited list, visited.contains neighbor. If it is not there, add this to the stack. Stack.push neighbor, N-E-I-G-H-B-O-R. Okay. For example, you were at number 2, so number 2 is not in the visited list, then add this to the stack. And then when you go to the next one is number 5. Is number 5 in the visited list? No. So add that also, number 5. Okay. Number 2 and number 5 are added to the stack. So the while loop continues. Again, the stack is not empty. At this point it was empty, but when you process the neighbors and they were not visited, so you added the neighbors, and now stack is like it is not empty, it has 2 values. So again you pop the last inserted node, which is number 5. So you remove that. Okay, number 5 removed, and then check, is number 5 already visited or not? So you see it is not visited here. So if it is not visited, add this to the visited list. Okay. As soon as you added this to the visited list, so you go checking its neighbors. The neighbors of number 5 is 1, 2, 4. So you check, is 1 already visited? Yes, it is visited. How about number 2? It is not visited yet. So if it is not visited yet, then push this to the stack. Okay, number 2. And how about number 4? Is number 4 visited? No. So push number 4 to the stack also. Number 4. Okay. So continue the while loop. The while loop, the stack is not empty. Then you remove the last inserted one. The last inserted one is number 4. You remove that. Okay, you process that. And when you process that, so is it in the visited list? No, it is not. So you add that to the visited list. Number 4 is added to the visited list. And now when you add this to the visited list, you check its neighbors. So the neighbors of number 4 is 3, 5, 6. So you go through all of them. First, is number 3 in the visited list? No. Then if it is not visited, add this to the stack. Number 3. And how about number 5? It is visited. Then you don't need to add this to the stack. And how about number 6? Number 6 is also not visited. Then add this to the stack also. Okay. So you added all the neighbors of number 4 also to the stack. So now the stack is not empty. Then you remove the last inserted node in the stack, which is number 6. Okay, then you process that. and then you check, is it already visited? No, it is not in the visited list, so you add that here. Number 6 is added. And when number 6 is added, you check the neighbors of number 6. So the neighbor of number 6 is number 4. Is 4 already visited? Yes, 4 is already visited, so you don't need to add that again. So the while loop continues. The stack is not empty yet, so you remove the last inserted one, which is number 3. Okay, you remove number 3, and then you check if it is already visited or not. It is not visited yet, so you put that in the visited list, number 3. And now you check the neighbors of number 3. So neighbors of number 3 are 2 and 4. So you say, is 2 already visited? Not yet. Okay, so you add that to the stack. How about number 4? Is number 4 already visited? Yes. So ignore that. So the while loop continues. It is not empty. Then remove the last inserted node, and that is there's 2. So is 2 visited? No, it is not visited yet. Then add this to the visited list. Okay. And now check the neighbors of number 2. Neighbors of number 2 are 1, 3, and 5. Is 1 already visited? Yeah, yes. If it is visited, then you don't need to add that to the stack. How about number 3? That's also visited, so you don't add to the stack. How about number 5? That's also visited. Then you don't need to add to the stack. And then the while continues. So you remove the last inserted one, which is 2. So again, is 2 already in the visited list? Yes. If it is already here, then the whole if block can pass, and you go to the while loop again. Is the stack empty? No. Then get the last inserted one, which is number 2. Is number 2 already in the visited list? Yes. It is already here. So if it is already here, then if is passed, and at this time that stack checks, say now the stack is empty. This means that you have traversed through every node in this graph. And see now how you visited that. So you started from number 1. We said that with DFS we go as deep as possible before backtracking. So you check number 1, number 5, number 4, number 6. See, all the way down, and then you start backtracking, number 3 and number 2. So it is how you traverse a graph when it is represented using a list with both of these BFS and DFS algorithms. I hope it was clear enough for you. I'm sure it was not as easy as you may think. You need to go through the codes and process again. But if there was any question, you can always ask your questions, then I will answer to the best of my knowledge. So a brief summary. Here first we created a list using hash map, because when we have a key value here, hash map is the best option that we have. So the key is also integer, and the value for this is a list, because you see this here, it is an array. So we use a list. That is the best option. And then we created a method to add the edges like this. So every time you pass, for example, the both ends of one edge, for example 1 and 2, 1 and 5, or 2 and 5, 2 and 3. So at first it checks if one of the end, for example, if it is 1 and 2, if one is already not created as a key, then you create that key, and the value should be an empty list. And then you check if the key already exists, then you add a value to that given key. So it was how you were adding edges, and then we implemented BFS, breadth first search, and then we implemented DFS. So I hope it was clear enough. Until the next lesson that we will represent a graph using a matrix and then use BFS and DFS. Have a nice time, and don't forget to share your questions.